students. In today's class, I am starting new chapter from Unit 9. Unit 9 is Electronic Devices and chapter is Semiconductor Electronics. Now, the importance of studying semiconductor is, in ancient times, the electronic devices were bulky, used to consume high power, which has limited life and used to operate in high voltages. Now, due to semiconductor devices, things have become much simpler, such as it has become small in size, which has low power consumption, long life, and low operating voltage. So that is the reason why semiconductor electronics is of great importance. Now, first of all, let us discuss about the material, which is how a semiconductor is made. Now, most of the materials can be placed into two categories: either conductor or insulator. Now, conductors are those where charge can flow easily, whereas insulators are those where charge cannot flow. This is what we know about conductors and insulators. The distinction between the conductor and insulator can be explained on the basis of number of free electrons. Charge means we are talking about free electrons. So in conductor, there are high number of free electrons which move freely, while insulators have practically no free electrons. Now, the temperature coefficient of resistance of conductor is positive. That is, resistivity or electrical resistance increases with rise in temperature. So, if temperature rises, electrical resistivity increases or electrical conductivity decreases. But it doesn't affect insulator, it only affects conductor. Now, there are, however, certain materials where electrical conductivity is intermediate between conductor and insulator. So, there is a material which lies between conductor and insulator. They are known as, which lies in between that device or that material is known as semiconductor, such as carbon, silicon, germanium are examples of semiconductor. In semiconductors, the outmost valence electrons are neither so rigid with the atom as in insulator or nor loosely bound as in conductor. So the electrons are intermediate, not tightly bound nor loosely bound. The temperature coefficient resistance of semiconductor is negative. That is, the electrical resistance decreases with rise in temperature. When temperature increases, conductivity increases. Resistance decreases, it means conductivity will increase. And at absolute zero temperature, a semiconductor becomes an ideal insulator. So when temperature is 0 Kelvin, semiconductor behaves like an insulator. So this is the property of semiconductor. Okay, this is the first thing. Now we'll study about energy bands in materials. Now, let us talk about the energy band in materials. A material consists of an enormous number of atoms packed closely together. Each atom, when isolated, has a discrete set of electron levels, such as, I'll just write it down. The level of the electrons in the atom is in such way, such as 1s2, 2s2, 3s2, 3p6, etc. This way electrons sit in different levels. Now, as we imagine, there are n atoms of the materials to be isolated from one another, then they would be completely coinciding set of energy levels. That is, the electrons fill the energy levels in each atom independently. As the atom approach one another to form a material, a continuous increasing interaction occurs between them, which causes each of the level to split into n distinct levels. Therefore, the split energy level becomes so numerous and so close together that they form a continuous energy band. The amount of splitting is different for different energy levels. In general, the lower level are split less than the higher levels, the lowest level remaining almost unsplit. The reason is that electrons in the lower levels are the inner electrons, such as, I'm talking about lower levels, which are 1n, 2. These are lower levels where the electrons are bound to the nucleus. If there is a nucleus, 1s, 2s will be, this s will be bound to the nucleus. That is why it is really difficult to remove the electrons from the innermost shell or innermost orbit. On the other hand, electrons in the higher levels are the valence electrons, such as electrons over here. This electron, which is there to be in this one, 3p, they are the valence electron. So they are easy to remove from the shell. Now in this figure, it shows the formation of energy band for some of the higher energy levels of isolated sodium. So this is for sodium. Okay, I'll write it over here. This is for sodium. Where ground state conformation is, for sodium it is 1s2, 2s2, 2p6 and 3s1. As the intermediate atomic distance decreases, the dashed line indicates the observed interatomic separation in the solid. So this line represents the separation in the solid. The 3s level are the first occupied levels to be split into a band. The 2p levels do not begin to split until the interatomic distance becomes smaller than actually found in solid sodium. The level 2s, 1s and 2s do not split at all. So we can see over here it is only 2p, but 1s and 2s, it lies over here itself, which is not being split because it has got very strong energy. Whereas as we go up to higher levels, 3s and 3p, it has been split because they have less energy. Now the energy band in the solid corresponds to energy level in an atom. An electron in a solid can have only energies that fall within this energy bands. So this can have energies in this type of energy bands. The various energy band in a solid may or may not overlap depending upon the structure of the solid. If they do not overlap, then the interval between them represent energies which the electron in the solid cannot have. These intervals are called forbidden gaps. Now I'll draw the energy level diagram of a solid, a simpler one, okay? So this type of energy bands are present in a material or a semiconductor or conductors or insulators, whatever material we talk about. Now there are different band. This shows the energies. Now the first band over here, this band is the valence band. Now I'll tell you the properties of valence band. Please note it down, okay? The first one is the energy band which is formed by grouping the range of energy levels of the valence electron. So over here only the valence electron is there. So this band where the electrons which valence electrons set are known as valence band. Valence band is present below the conduction band. So this band over here is known as conduction band. So valence band is below the conduction band. Electrons in valence band have lower energy than the energies in conduction band. So electrons of valence band have got less energy than that of conduction band. The electrons in the valence band are loosely bound to the nucleus of atom. That is the last point. Now whatever points I have just told you, just write it down. Now next, about conduction band. The energy band, which is formed by grouping the range of energy levels of the free electron, is called the conduction band. All the free electrons, they sit on the conduction band. So after grouping the energies of free electrons, we get a band known as conduction band. Generally, number 2 point, the conduction band is empty, but when external energy is applied, the electrons of the valence band jumps to the conduction band. So if external energy is there, the electrons from this band jumps to the upper band. Second point. Now the third point. Electrons in the conduction band have higher energies than that of electrons in the valence band. Now the last one is, the conduction band electrons are not bound to the nucleus of the atom. They are free electrons, they are not bound, and they are free to move. Now the gap between conduction band and valence band is known as forbidden gap or forbidden band or energy gaps. Okay, the energy gap which is present between the valence band and the conduction band by separating these two energy bands is called forbidden band or forbidden gap. Now this is about forbidden gap, conduction band and valence band. Okay, now the next is classification of materials on the basis of energy band concept. Okay, now without going in much detail, I'll just give it a diagram. Okay, first of all, we'll draw for conductors. Now for conductors, this is the energy, this level shows the energy. Now first band is valence band. This is valence band. Now in conductor, valence band and conduction band, they overlap. Okay, the upper band is, I'll draw with a different color. The upper band is conduction band. The lower band is valence band. So valence band and conduction band, they overlap. The energy gap is 0. The energy gap between the valence and the conduction band is 0. So in conductor, valence band and conduction band overlap. So it is easier for the electrons in the valence band to jump to the conduction band because there is no gap over there. The few example of conductor is beryllium. Okay, one of the example is beryllium. Or this is a material sodium. Material sodium is also conductor. So few more properties are also given in the book. For your understanding, this diagram is enough for separation of different materials on the basis of conduction band. If you have to draw a diagram, then this diagram is enough. Now let us draw for semiconductor. This level is energy. Now the first band, this band over here is valence band. The upper band is the conduction band. Now there is a gap. That means the energy of the valence band is greater than the energy of the conduction band is greater than the energy of the valence band. The gap of energy, the difference of energy, is greater than 3 electron volt. So this is the amount of energy difference in a semiconductor. It is not same for every semiconductor. It might be different for different types of semiconductor. So energy gap is less than or in between 3 electron volt. Now the third type of material we are going to talk about is insulator. For insulator, this is conduction band, this is valence band. The energy gap is greater than 3 electron volt. So the energy gap is so much that the electron from the valence band for the electrons of the valence band is not possible to jump into the conduction band. That is why this type of materials are insulators. Even at very high temperature, there is no exchange of electrons. The electrons will sit in the valence band only. So these are the classification on basis of energy band concept. So for today, we'll keep it up to here. In next class, we'll discuss about types of semiconductor. Okay, and with one more class, we'll be able to finish this chapter also. So whatever I've told you, if I'm speaking too fast, do pause the video and do make the note of everything which I've told you. Okay, every note which I've given to you. So this much for today. Thank you.